All right, so some more big picture main points of review. When we're talking factoring, the first type of factoring that we always want to look for is the GCF, which is the greatest common factor. And that's basically what you can divide out of every term. Remember, it's the opposite of distributing. So your answer when you factor something with GCF, will always look like a distributing problem. So you'll have the GCF, and then you'll have whatever was when it was divided out, whatever was left. Um, the stuff in the parentheses of what's left should always have the same number of terms as what you started with when you take out a GCF. The other types of factoring that are pretty formulaic and straightforward are the binomial ones. So the first one is the difference of squares. And I wrote this a little bit different. So it's thinking of ax squared minus bx squared. So you have perfect squares, and then you have one minus sign with it. And then it is two sets of parentheses. One gets a plus in the middle, one gets a minus in the middle, and it's the square root of ax squared, which is the square root of a times x, whatever that number is, plus the square root of b plus y, and then the same in the other one with a minus sign in it. Remembering with this, the way that it's written, a and b's are considered perfect squares. So that square root of a and square root of b, those are going to be perfect numbers. They're going to be numbers that are something squared equaled the a and the b. Sum and difference of cubes. I wrote these as two separate ones. They are very, very similar. So when I have a cube plus another cube, so the exponents have to be multiples of 3. It's still two terms, and all the coefficients would have to be perfect cubes as well. Then what you do is the first set of parentheses is what was cubed. So basically taking the cube root of everything that you had. So divide the exponents by 3, find out what number times itself was that perfect cube. And that is your first set of parentheses. So a plus b. And then you are going to be multiplying two things at a time to get the next parenthesis. So starting from your little parenthesis, which is the what was cubed, you're going to square the first term. You're going to multiply the terms together and take the opposite. So you have a squared minus ab, and then you're going to square the last term, so b squared. If you were subtracting, you're going to have that first set of parentheses is going to be the perfect, whatever was the cube root, so whatever was multiplied times itself 3 times, minus the other cube root. And then you do the same thing, you multiply the first term times itself. You multiply the terms together and take the opposite. So a times negative b is negative ab, and then I do the opposite. So that is going to be a plus ab in the middle. And then you take the last term and square that. So negative b times negative b is b squared. All right, so we've got some examples. I didn't put the fourth example in yet. I will put that in after we go through the first few. So looking at what we have, so the first one, it's a factor completely. There are 3 terms, so I know it's not one of my special ones, the difference of squares or the difference of cubes. So this is my GCF. So I'm looking at what I can divide out of 12, 4, and 16. And remember, if my first term was a negative, I would take out a negative with it. That would be part of my GCF. So looking at it, I always look at the smallest number. Does that go into both of all the other ones? So 4 does go into 12, 4 goes into 16. So this is good. So I'm going to be taking a 4 out of every term. And remember, a fraction just means divided by. So then I'm going to start my GCF is going to have a 4. Then I look at the letters. Do they all have the same letters? Yes. This time they all have X's and Y's. So I am going to be taking out both X's and Y's from both of them. From all the 3 of them, excuse me. And then I'm looking at what is the most I can take out of every single term. So I'm looking for the smallest exponent because I can't do negatives. So I have 5x's here, 3x's here, 6x's here. So that is going to be 3 is the most I can take. So I'm going to take 4x cubed to start with. And then I look at my y's and I have exponent of 3, no exponent. So that's an exponent of 1 and an exponent of 2. So that means I can only take that exponent of 1 out. So I'm going to be dividing by just a y. I could put that 1 if I wanted, but I think it'll just add to a little bit of confusion. All right, now I'm going to reduce each one of these fractions. So I'm just going to simplify what I have. I'm going to change colors a little bit. Hopefully that'll work. So 4 goes into 12 3 times. So this becomes a 3. I have 5 x's on top and 3 on the bottom. So that means I have 2 more on top. So this is going to be an x squared. And I have 3 y to the third and a y to the first. So I'm going to take 1 away from the top. There's more on top. So this becomes a 2. And then I look at the next part. I've got a negative 4 divided by 4. That equals 1. I am going to write that to start with, just in case everything else cancels out, and look at my x's do cancel out. Same on top, same on bottom, same on top, same on bottom. So it's just a 1 for that term. It just reduces to that. So the coefficient of 1 is a good number. 4 goes into 16 4 times. It's a positive, so plus 4. I have x to the third on bottom, x to the sixth on top. So this is going to be x to the third because it's 6 minus 3. And then y to the first, y to the second. So this just becomes a y to the 1. So they've got x to the third, y. All right, so my final answer, I'm going to change the color of that last bracket, is my GCF is 4. Sorry. My GCF is 4x cubed y. And then the rest of my problem is going to be in parentheses. What's left is going to be 3x squared y squared minus 1 plus 4x cubed y cubed y. All right, so that is as factors as I can get it. Sometimes I will have to double check the stuff in parentheses to see if I can factor any more. But in this case, that is all I can do. All right, so then I have 2 terms. The exponents are even. The coefficients are perfect squares. I've got 16 and 81. So this is 4 squared and 9 squared. Exponents are even. So this is a difference of squares, even, and I do have the minus sign. Even though it's not a 2, it is an even number. So this is a perfect square. So I start by making 2 sets of parentheses. A plus sign in the first one, a minus sign in the other. And then I have to say what times itself is 16. So it is 4. And then I divide the exponent by 2. So m to the 8th is going to be m to the 4th. Okay, so 4m to the 4th goes in the front of both of those parentheses. And then this what times itself is 81, and that will be 9. So 9 goes in the back of each one of those. Now, I do have to double check when I am doing a difference of squares or any of the other ones that my first set of parentheses or that my any of my parentheses aren't still a difference of squares or anything special. The plus sign means it's not for the first one, but I have a minus sign here. And if I look at it, 4 and 9, those are perfect squares. My exponent is still even. So I do actually have to distribute that second one. It is still a difference of squares. So the first one is going to stick it out. So that is going to be a 4m to the 4th plus 9. That one can't change. Then the second one is going to be 2 sets of parentheses, a plus and a minus. And what times itself is 4, and that will be 2 and 2. Divide the exponent in half, so I have m squared. So I have 2m squared in the front of both of these. And what times itself is 9, and that will be a 3. And a 3. And if I look at all my coefficients, they are not still perfect squares, so I don't have to look any further. Even though I have an even exponent, I do not have a difference of squares for anything else. So my final answer is going to be the 4m to the 4th plus 9 times 2 times the quantity 2m squared plus 3 times the quantity 2m squared minus 3. All right, so the third one is I'm looking at it and I kept things in order because I was in that type of mood. This is 2 terms, which is good. The exponent's a multiple of 3. It's actually a 3. And 125 is a perfect cube. I do recommend knowing your perfect cubes generally to at least 10. And sometimes you need a little bit more, but you kind of get a feel for what it's going to need. So when I'm factoring this one, the first thing I say is what times itself is n to the third? What times itself 3 times is n to the third? So that will be an n. I have a minus sign. And then what times itself 3 times is 125? That will be 5. All right, so that is what the cubes are. I could have rewritten this as n cubed minus 5 cubed, if that's what if that helps. And then I'm just taking that base stuff, the base numbers. Now I'm going to use my first parenthesis to fill out the rest because it does follow a pattern with that. So it's n times itself, so n squared. N times -5 is -5n, but I have to take the opposite, so it's going to be plus 5n. And then -5 times itself is -5 times -5 is plus 25. So this is factored. Okay, and then for the last one, we will give us a little bit of a challenging one. Just because I can. So I am going to give us 2 x to the 6th minus 128 y to the 6th. All right, just because I can. All right, so it's still 2 terms, but I always say, can I factor, since it's a regular problem, I get sloppy and sometimes I forget to, but I should say, what can I take out of both of these? Because A, the numbers are bigger than I like to deal with. 128 is not a number I recognize, but I do notice that it's even and I have a 2 in the other one, so I do probably want to take out a 2. Looking at the letters, they are to the 6th, which I don't really like, but they're not the same bases, so I can't pull that out, but I can pull a 2 out. So this is going to be a 2 times x to the 6th minus 128 divided by 6 is 64 y to the 6th. All right, so now I have a challenge. I have numbers that are both, it is a difference of squares because my exponents are even and 64 is a perfect square. And it's still a difference of cubes because 64 is a perfect cube. And looking at it from that perspective, I'm not liking this. So, so what I can do, there's going to be a couple different answers of how you can do it. I would probably do the perfect squares, the difference of squares first, because I'm more comfortable with that. But I could do the difference of cubes first if I really wanted to. So I'm going to call this is 2, and then I'm going to say that this is x to the 3rd squared minus 8 x to the 3rd squared. So it's a difference of squares. So I still have that 2 hanging out. And then a difference of squares gives me 2 sets of parentheses, a plus and a minus. And what was squared? It's x to the 3rd, x to the 3rd, and 8x to 8y. That's a y. Y to the 3rd. Okay, then looking at this, I have a sum of cubes and a difference of cubes. So this is going to be a little bit more work. So I still have that 2 hanging out, and this is x to the 3rd plus 2 to the 3rd y to the 3rd. And this is x to the 3rd minus 2 to the 3rd y to the 3rd. All right, so I get to do my sum and difference of cubes for each one of these. So I've got 2. And then I'm going to say what was cubed. So this is x plus 2y. And then I multiply the first times itself. So this is x squared. Multiply them together. So x times 2y is 2xy. Make it opposite, negative 2xy. And then plus 2y times 2y is 4y squared. And then it's times, the other one is going to be x minus 2y. And then it'll be x squared plus 2xy plus 4y squared. All right, so just to make things look a little less cranky, it's still not going to be pretty. I could say that my answer is 2x plus 2y, x minus 2y for worst case scenario, and then I have x squared minus 2xy plus 4y squared. I can't do anything else with this because they're not like terms, and I'm multiplying things, so I've got it about as nice as I can do it. And then x squared plus 2xy. Yeah, so that's about all I can do with it. Final answer is really big, but it started with x and y's to the 6. So that is a worst case scenario. I probably wouldn't expect to see something like that, except for maybe as a bonus. But keep in mind, GCF always first, and then look for those special cases. We're going to look at trinomials in just a bit. I'm going to save my page and come up with new directions and stuff. Well, review of steps and then some examples. So we're going to do trinomials in just a minute. Okay, so for factoring with trinomials, so quadratics, so ax squared plus bx plus c, there's a couple different cases for how we do it, depending on if our a is a 1 or not, but we're going to do it all kind of together. So you're going to get extra practice with it. It's always, whenever we factor, we always want to see if there's a GCF to pull out to begin with. A lot of the times when we have you factor, we're only going to have you do one type of thing. So the GCF isn't always going to show up, but we should always check for it. And then what the whole purpose of with these trinomials is to get a problem that looks like a foiling problem, where we have two binomials being multiplied together. And to get that, we multiply the a and the c, so the lead coefficient, with the constant, and then we list those factors of that product. And then what we have to find is we need to find the factors of that product of the a times c that are going to combine, either add or subtract, to get to that middle term, that b, the bx. So if c is positive, we're going to be adding those factors. They both might be negative, but they'll be the same sign. And if c is negative, then we're going to subtract to get that b, and going with, it might be positive, it might be negative, depending on if we subtract the bigger number, the smaller number. Then we have, once we have that factor pair, we have two options for how to go forward. We can either rewrite the problem and turn it into a 4-term problem, so basically anti-FOIL it so that we see what we had when we combined like terms, and that would be doing some extra GCFing. Or we can use a guess and check, which is using those factor pairs and looking at where we need them to show up to find your factors. So we're going to show you both ways. The easier way probably is to factor by grouping, using the 4 terms. If you are going into a STEM field and need to do, I know you're going to be doing a lot more factoring, the faster way to get to factoring is to use a guess and check and to see where things are coming from. However, it will happen as you do a lot of factoring. So whichever way works better for you, make sure that you can work with that way. You do not have to know how to do both ways, but you do need to know how to be efficient and consistent with one of the two. All right, so we are going to start by factoring. We have 3 problems. We'll probably do a few extras after that, but we're going to start with our 3. And we are going to change colors to, I think I'll use this color to start with. All right, so when I have 2x squared plus 14x plus 24, first thing I notice is all of those coefficients are even. I always want smaller numbers rather than bigger numbers, so I'm going to pull out the 2 from everything to begin with, and then hopefully I will have something that is a little nicer. So this is going to be 2 times x squared plus 7x plus 12. All right. So my lead coefficient, the 2 is part of my answer, but it's not my lead coefficient. So I'm really looking at the stuff in the parentheses, which is my x squared, which is 1x squared, plus 7x plus 12. With that, my lead coefficient is 1, which means 1 times 12. I'm really just doing the factors of that back number. So my factors of 12 are 1 and 12, 2 and 6, 3 and 4. Now, 12 is positive, so that means I'm going to add my factors to get to that positive 7, and I know that 3 times 4 is 7. So if I'm doing this the 4-term ways, I have my 2 hanging out, and then I'm rewriting my problem. So I have x squared. Instead of that 7x, I'm going to rewrite it as plus 3x plus 4x, because those are the factor pairs that I need, and then plus 12. Now, there's a whole bunch of other ways to do this. This is a nice one, so there's a lot of shortcuts. But if I'm going through and looking at what I have, this will work for every single possible case. I'm going to be grouping 2 at a time. Look for your GCF. So there is an X and an X from these two. I'm going to put my 2 down for my answer because I don't really want to deal with that. So X, and then if I pull out the X, I will have an X plus 3. And in these two, it's a positive, so I'm pulling out a positive. And I can pull out a 4 from both, so plus 4. And 4x divided by 4 is x, and 12 divided by 4 is plus 3. My parentheses should match. They are my next GCF. So really what I'm thinking is I'm pulling that out. So I'm dividing by x plus 3 and dividing by x plus 3. So my GCF is x plus 3. I pulled that out. And when I pull that out, I am, whoops. Wrong button. All right. Nope, I can't erase it. All right. All right. Change colors. Sorry. Pencil, red. Okay, and then what was left is my other set of parentheses. I'm doing it in 2 colors just so you can see it. And plus 4, because this canceled with that. And that would be my factors. Now, I could have used what I know about the factoring difference of squares. So, or guess and check, basically thinking foiling. Okay, so if I'm foiling, I know I have 2 parentheses. The first is the factors of that first one. There are no choices. One is just the factors of x squared are just x and x, because you need an x in both of them. So I have an x and an x. The factors of 12, these two have to combine to equal that middle. So x times this one, x times this one, those would be my 2 factors. So I need one to be a 3. So x times something equals, that will put my 3 here. And it was a positive. And this x times something has to equal my other factor, which is 4. So there's my 4, and that is how it factors. Or basically, it's the factors of last at the end. That is kind of the guess and check. We are still doing the all the factors. We need to list the factors and find the factor pair that works. Both ways will get you the same answer. It doesn't matter if you have an x plus 3 and then the x plus 4, or the x plus 4 and then the x plus 3. Because that's how it's going to go. All right, so we're going to look at the next one. This one we have 3x squared minus 5x minus 2. So we're going to multiply the first and the last term, the 3x. So 3 and a negative 2 equals negative 6. This means, because it's negative, is subtract. And I need my factors of 6, which are 1 and 6, and 2 and 3. And I need to subtract to get to a -5. So a lot of times what I will do to organize myself is I needed it to multiply to -6. I need it to combine to a -5, and I know I need to subtract. And if I'm subtracting to get a -5, I need to go 1 minus 6. So 1 minus 6, that is the factors that I'm going to need. If I rewrite my problem, I'll have 3x squared plus 1x minus 6x minus 2. All right, factoring those two at a time, I can pull out with these two. And then these two, with the first two, I can pull out an x. So I have x, and I have 3x plus 1. With these two, it's starting with a negative, so I'm going to pull out a negative. The only number that goes into 2 and 6 is 2 or 1, but 1 doesn't help me, so I'm going to divide out a 2, and so that will be a -2. -6 divided by -2 is 3, and then I have the x. -2 divided by 2 is -1. Now I have my parentheses are the same. That is my GCF, so I'm going to divide that out. Plus 1, 3x minus plus 1. Yep, because I have a minus. I got sloppy because I'm dividing by a negative. Negative divided negative is positive. So I do need to make sure that I write that correctly. All right, factoring that out. So 3x plus 1 is what was in common. That comes out of both of them. And then what was left, and I could keep it all in one color, but I will just keep it like that, -2. Now, if I was thinking of how to do this using my factoring ways, okay, so I've still got the problem. This is still the same problem. I don't want that there. Change my mind. I want to erase. All right, so I can think of my two parentheses. All right, and my factors, if I'm thinking about this, my factors of 3, I'm going to rewrite the problem here. 3x squared minus 5x minus 2. So my factors of 3, there's only two choices. It's 1x and 3x. All right, so there aren't choices for that. For 2, the only way I can get 2 is 1 and 2. So this has got fewer options. It's kind of similar to when my coefficient is nice, except I have to think a little bit further with those what works. All right, so I'm going to put my factors of my 3x squared in the front of the parentheses. So I'm going to put my bigger number first. So 3x and 1x, or just x if you want. Now, I know when I'm doing this, I'm going to pick a lighter color just so that we can see what is going. I know 3 times something has to either equal, because remember I'm using the 1 and the 6, it either has to equal 1 or -6. Now 3, there's no way unless I'm using a fraction to get to 1. So this has to equal -6. So 3 times what equals -6? 3 times -2. Now we can think of the other one we're going to do is x times something has to equal 1 or -6. I already got the -6 taken care of, so I need to get the 1. 1 times what equals 1? That is a 1, and it's a positive 1. And then just double check. The -2 times 1 equals your -2. So that is the same factoring with it. It's just how you do the guess and check a little bit. All right, so the last one we're going to do right now, and then we're going to start another one. I'll save my page and then write a couple more problems just so we can have more practice for you guys at the end of the video. Then we have 3x squared plus 11x minus 20. So this is another subtraction one. I have 3 times -20 is -60. There are a lot more choices for 60. That just means subtract. And if I'm doing my X thing, I have a negative 60. I'm going to be subtracting and getting to a positive 11. So I want something minus something else is going to equal to 11. All right, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. 7 doesn't go in there. 8 doesn't because 4 is with an odd number. 9 doesn't because it doesn't add up to 9. And then I'm back to 10. So those are all of them. If I want to get 11, I'm going to be using 15 and 4, and I really want it 15 minus 4. Rewrite my problem. I'm going to start that way. I'm going to do a little, so the 11 is going to be 15x minus 4x, or negative 4x plus 15, your choice. So this is 3x squared plus minus 20. All right, just for a little bit more color. All right, dividing out of those two, pick these two. So 3x squared and 15x, I can pull out a 3x from both of those. So that will give me 3x parentheses x plus 5. I'm pulling out a negative 4 from the second two. So minus 4. X plus 5. My parentheses should match, and they do. I'm running out of room, so I'm not going to do that division of showing it. So that will give me an x plus 5 times a 3x minus 4. Make sure you pause and see where that's coming from if this is the way that you want to factor. Totally fair. The other way that I can factor this is I can take my 3x squared plus 11x minus 20. I know 3 does not have a lot of factors, so 3 is really just 3x times 1x is getting me to 3x squared. That's my only choices. 20, there's a whole bunch more ways. I could do 1 in 10, 2, or 1 in 20, 2 in 10, 4 in 5. So there's a few more choices with that. So if I start my parentheses, the first term only has the one choices. So I'm going to put the 3x and the 1x. I can write some days. Okay, so this is 1x. So I'm just going to call that x, or 1x. And then remember, I need to get 3 times something equals either 15 or negative 4. So 3 does go into 15, so it's not going to be the negative 4, which means this one has to be my negative 4. So 3 times 5 gets me to 15, and it has to be a positive 5. Now that leaves that negative 4 to be the other two. And if I'm thinking about that, 1 times negative 4 is 4, negative 4. And that is the factor pair that I was using with this. 5 times negative 4 is negative 20. So it all works with that. And my answers are the same. Doesn't matter which parenthesis goes first. So there's a couple different ways to factor trinomials. We were going to do a few more in a little bit. So I'm going to save my page and then we will come right back. All right, so we're going to factor 2 more problems that are the quadratics with a little bit more work. So we have lead coefficients. So what we're going to multiply is for the first one is 2x squared minus 9x plus 9. So to see if it factors, we need to multiply the lead coefficients, so the 2, and the constant. So 2 times 9 equals 18, and it's a positive, so that means we're going to add. Your factors of 18 are 1 and 18, 2 and 9, 3 and 6. I need them to add together to equal a negative 9. So I think of it this way, is I have 18, it's a plus. So I know I'm going to do a plus. And they have to combine to a negative 9. So 3 and 6 add to 9, but to get to a negative, it'll have to be a -3 plus a -6. Since I've got a plus and a minus, I really would just think of just the minus with that. So this is going to be 2x squared minus 3x minus 6x plus 9. Factor from those two, factor from those two. Pulling out of a 2x squared and a -3x, I can only pull out an x. So that gives me an x and a parentheses 2x minus 3. Between a -6 and a 9, it's starting with a negative, so I want to pull in a negative. And 3 is the only thing that goes into both of those, so I'm pulling out a -3. Make sure I write the negative under both of them. -6x divided by -3 is a positive 2x. And 9 divided by -3 is a -3. My parentheses match. That is my GCF. So I'm dividing that out. And then what is left when I get rid of the parentheses is going to be an x minus 3. And then if we want to, we can test out if we can do it with a guess and check. So this would be the 2x squared minus 9x plus 9. My 2 has the factors of 2x times x. 9's got a couple choices. I've got 1 and 9 and 3 and 3. So if I'm factoring it, I can put the first one because there's only the one choice. So I'm going to put 2x and x. And remember, this times this has to equal one of the factors. So it has to equal either -3 or -6. 2 goes nicely into -6. So that's the one it's going to be. 2 times -3 is -6. And that means these two, the x has to equal the other one. So that has to equal -3. So that gets my -3. And if I look at it, my factors are exactly the same as my other one, so I could do it either way. Both ways work. Just go with which way makes sense to you. Don't go by with which one is less writing. That's not necessarily the best way to do it. What works for you, what makes sense for you is the whole intention of what you are going to be doing. All right, so last one that we're going to do in this video, we might make another video of more factoring just to give you some more practice. But so this time we have 3x squared minus 10x plus 8. So we're going to see if it factors. So we have a 3 times 8 is 24. It's a positive, so that means add. Your factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. Any of those add to get me to a -10. Okay, so I know what they have to add. They're 24. And they have to get to a -10. They do. If I did not have a pair that would add or subtract, depending on what I have to do, to get to that middle term, then it would be a not factorable. So this is a great way to tell if I can't factor something at all. In this case, I know 4 and 6 is 10. I need it to be negative, so I'm going to do a -4 and a -6. Since I have a plus and minus, then minus takes over, so it's just -4 and -6. Factoring by grouping, so 3x squared minus 4x minus 6x, because that replaces that 10x, and then plus 8. Factor from those two, factored from those two. Can only pull out an x out of the first two, so then I have an x and a 3x minus 4. I'm going to pull out a -2 because they're both even. It's starting with a negative, so -2. -6x divided by -2 is 3x. 8 divided by -2 is -4. Parentheses do match, so my factors are 3x minus 4 and x minus 2. Remember, it could go if you put the factors in the middle the other way. So if I would have done negative 6x minus 4x, it will still factor. You'll just have the factors in the opposite order. Totally fair. If I'm redoing the problem, thinking guess and check, because that is another way to think about this, I will have the 3x squared minus 10x plus 8. So 3 has the factors 3x and x. That's the only choices. 8 is 1 and 8, 2 and 4. All right, so 2 parentheses. I'm going to do a 3x and an x. Thinking other color because it gets messy. So 3 times something has to either equal negative 6 or negative 4. 3 goes into the 6. It doesn't go into the 4. So this is negative 2. Now, occasionally it could go into both, and then I have to look at the other factor and see if that's one that's going to limit it. So we might do another video with some extra ones, but in this case, they should be not out to trick you guys. So I'm hoping that we won't give you terrible ones. So factors match. And that's how we are going to factor. So I might make a separate video of just factoring trinomials, because I know some people are struggling with these trinomials, and it's pretty important to know how to factor for college algebra and beyond.